Well, hey everyone, how's it going? Today we're going to be kind of looking deeper into the world of fractions, and we're going to kind of talk about the sums of fractions, right? So let's, of course, as always, break apart what all of this means. If we're talking about sums, first thing that we really want to come to mind is that idea of addition, right? The sum is the answer to an addition problem. That's a sum. So we're thinking about using addition with fractions. How do we add fractions together? If I'm given a certain amount, right? For example, if I have 3/4 and I have to add 2/4, like what is that going to mean? Like how do I get there? So that's what we're going to explore today. Let's kind of take a look and just dive in, as always, to be thinking about this concept and what's happening. So let's, first example, I don't know, we got 1/4. We'll start with this, and let's add 2/4. Okay. So in theory, with anything with addition, right, I might look at this and say, oh, well, this looks good. I'm going to say that 1 + 2 is 3, and 4 + 4 is 8. This must be 3/8, right? That would be a common approach to how to do this, but it is not how things work. We really do need to think about what fractions are and what's happening here. So let's explore that. If we're going to look at the sums of fractions, I think one thing that's really important is let's look at the fractions, right? So let's go ahead and model first. Let's model what these fractions look like and think about what would happen if I was to put them together. I have the first model here, which is 1/4, and I'm going to draw the second model right next to it as well, right? So this is what each represents. And as again, the denominator tells us here, we have 4 equal parts, and one of them is shaded. And if we come over to the second one, same concept, 4 equal parts, and 2 of them are shaded. So if we thought about if we were to add that together, right? If we thought about how to put that all onto one model, it's like we're just going to put them all onto one model. If you look over here, the reality is I still have force. Like no matter what, my denominator is still the same. I still have force. I've taken my whole, and it's still 4 pieces. That doesn't change. I'm not adding how much I've cut it into, right? I'm adding the numerator. It's the numerator we really need to be thinking about, is the parts we're putting together. The denominator is exactly the same. So let's just look. How many shaded pieces do we have between the two of them? I have 1, 2, 3. So that just means if I go to my answer, I got to shade in 3 parts. And if we look at that, there you go. We actually have 3 force. And that would make sense if you think model wise, right? If let's just take, for example, these are 2 different pizzas, right? Now both pizzas were cut into 4 slices each. And after people ate their pizza and we had some fun, we had some left over, and we just look, oh, well, this pizza, there was 1 slice left over. This pizza, there were 2 slices left over. So altogether, there's 3 slices left over, right? 3 out of 4, because that's what we cut each pizza into, is 4 pieces, right? So that's kind of how this process works. We think about the idea that we can model our fractions, right? And then we'll put them together. Let's see. Yeah, I don't know. We'll just say put them together. And then we can write our sum, right? So write the sum. I put that into fraction form. I made models, and then I took my final model and rewrote it as a fraction. So, you know, model it, put them together, and write as a sum. So let's play along. Let's keep going. So let's say I have 1/8, and I'm going to add 3/8, right? What is this going to mean? Well, where do we start? Well, I say let's start with a model. Let's model each of these. And one thing that is very important is when I'm comparing or modeling or adding, right, I want my models to be the same as best as I can. And I'll be honest, I don't think this is the best I can. So let's that didn't do much different, but okay. So now this 1/8, let's cut this into 8 pieces. So I need nope, let's redo that. I need 1, 2, 3, 4, and that would be 8 total. 2, 4, wait, no, that would not. 1, 2, 3, 4, 5, that's 10. Okay, oh, let's go back to this. Whew. All right, so I need force first. So I'm gonna do 3 lines. That's where I made the mistake. and then down the middle. 1, 2, 3, 4, 5, 6, 7, 8. There we go. All right, so I'm gonna just use this to copy. Okay, and this one is 1/8, and this is 3/8. So if we were to put this together, and I'm just going to use the other models to help me. I'm just kind of like moving my pen across. That's not very equal, is it? But that's okay, because this will still get us a sum, a solution. Let's see. Let's put how many we have. We have 1, 2, 3, 4 pieces. So let's shade in 4 in our final model. And there is our final answer. It has now become 4/8. And if you look, this is kind of the trend you can see happening here, is that the denominators staying the same. It's the numerators, it's the pieces we're adding together. So that's another approach we could think about as we do this. So as always, let's just try a couple more, because I want us to explore kind of what happens as this grows and changes. So let's see here. Maybe I'll do 3/4, and let's add another 3/4. Okay, so 3/4 plus 3/4. All right, so let's kind of put this together with a couple things, right? We're gonna first model. So let's model what we have. And again, I want my models to be the same, and in this case, they will be the same because it's the same fraction. The denominator tells me 4 equal parts, and then this is 1, 2, 3, and this is 1, 2, 3. I'm gonna add these together. So let's build. Okay, and if we think about this now, let's go count our pieces. We have 1, 2, 3, 4, 5, 6. Well, I have to shade in 6. Okay, cool. Let's do that. So I got 1, 2, 3, 4, 4, 4, 4. Wait. So I have 6 pieces over here to shade all together, but over here I've only shaded 4 so far. So what does that mean? What are we going to do? Well, what that means is we filled one hole up. We need to start thinking about the fraction of the next hole. So the reality is since I needed 6, this is only 4 over here, right? This is only 4 right here. So I'm going to need some more. So we're going to build another model. Again, still in fourths, and then shade in what's left. Let's see. So I needed 6, and I just shaded 1, 2, 3, 4, 5, 6. So what does this mean for an answer? Well, let's remember here that no matter what, I'm working in force. My denominator is the same. It has not changed. So we know that no matter what, I have force. Well, how many of these force do I have? I have 1, 2, 3, 4, 5, 6. So I have 6 force. And this is the first time we really start to see this idea of something that's called a top-heavy fraction. And there will be more to support this and what that means, but this is a top-heavy fraction. Like what do we do here? And this is an acceptable answer at this point, because that's what this is. It's 6 out of 4. But if we wanted to look at it as what is this really written as a number, like how do we really take this in, write it in what we like to kind of call the proper way? Well, let's look at this model we have over here. Right? Let's check this model out over here. This model over here, what we've done is we first filled one whole thing. So that's actually one hole. It's one hole right there, right? This is 1, because we got all of it. And then what's left over here is 2 out of 4. And these are equivalent. And there will be more videos about that, but we want to put that in for now as we think about that. So this can happen when we're adding fractions. Is sometimes we're going to get more than one whole when we add, which means, of course, let's just do another one. Let's do tenths. Let's go crazy. We're going to do 3 tenths. We're going to add 7 tenths. Okay, so let's look at a couple things. First, let's think about mathematically what we've learned in this case. Without modeling, one of the things we've seen that's happening is that my denominator is not changing. So in theory here, I should have 10, and then we're adding our numerator together. So that's 3 plus 7, that's also 10. So I guess if I look at that, what we talked about before, if I have 10 out of 10, right? Or this also says 10, and this fraction line does mean divided by 10. 1. So technically speaking, the answer to this is 1 whole. So that's mathematically, we can look at that, right? Mathematically, sorry, this is what we were thinking. That's what those little dots were. It's like a thought bubble. So let's do that as we model that. Let's see what happens when we model to see if we get the same thing, because that's one way. We can look at, hey, I understand how to model this to get an answer. I also understand how I can use it mathematically. But let's do them both to see if they check off. Like if I do it one way and I get a different answer than the other way, maybe I need to revisit my understanding of some of this, right? So we're going to need tenths. So 1, 2, 3, 4. And that creates tenths. 1, 2, 3, 4. And that creates tenths. Okay. And this is 3. 1, 2, 3. And this one is 7. 1, 2, 3, 4, 5, 6, 7. Right? And 7 tenths, 3 tenths. We're going to put these together. So let's see, 1, 2, 3, 4, boom, there's 10 pieces. So let's count up what we have and then move them into the final model. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total pieces. So I need to shade in 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which again, we can see we just shaded all of it in. We just shaded the whole thing. So if we have the whole thing, it's true. We just have 1 whole. So this pans out, this checks out. So this is this way we can kind of look at that. So keep thinking about this process. There's going to be more videos. This is kind of introduction to be thinking, and we'll be looking at some more as we go. But as always, appreciate your hard work and thank you for being here. And we will see you very, very shortly.